Alright, so we're talking about infinite geometric series. Infinite because they're going to go on for forever, and geometric because we have a common ratio. And so I'm going to start off just by writing out this series by plugging in, starting at 0 and then just going on up. We're going to plug in 0 for I, and so that'll give us 1/10 to the 0, which is 1, so first term is 0.3, plus 0.3 to the 1/10 to the first, so 0.3 times 1/10 is 0.03. Move the decimal one spot, and then we're going to square 1/10, so we're going to move it twice, and you get the gist. So we're going to end up with 0.3333, and you can sort of tell. And so if we were to add all this up, and to be able to write 0.333 as a fraction, we all know that this is 1/3. But some fractions we're not very good at, and so I'm going to teach you a way of writing that as write a repeating decimal as a fraction. So, formula for the sum of a geometric series. First term, a sub 1, divided by 1 minus r being the common ratio. So where does this come from? Well, the sum of our geometric series was a sub 1, 1 minus r to the n, 1 minus r, and we use this for anything. And so now if n becomes infinity, let's treat this as if you raise r to the infinite power, it's going to continue getting smaller as long as r is less than 1, the absolute value of r. So, thinking of our first term, 0.3, 1 minus r, which is 1/10, being raised to the infinite power, divided by 1 minus 1/10. So 1/10 to the infinite power, if you keep multiplying by 1/10, it's going to continue getting smaller, and so that's going to disappear, become 0. Anything to the 0 infinite power is going to go to 0 as long as it's getting smaller and smaller and smaller every time. So 1 minus, so this minus is gone, so you end up with 0.3 over 1 minus 1/10, or 0.3 over 9/10, or 0.3 times 10/9. So multiply by 10, you get 3/9, or 1/3. And so that's how that works. That our 0.33 repeated is equal to 1/3 because of this infinite geometric series. Very, very important point is that r has to be less than 1. If it's not less than 1, your series is going to grow rather than shrink. This works because it's getting smaller and smaller and smaller every single time. So, a few problems to try out. Plug in 1, 8 to the 0.4, 1 minus 1 is 0, so that's 8 is our first term. And then we're going to multiply by 0.4 every time, so 8 times 0.4, next term is 3.2, next term is 1.28, 0.512, and so it's getting smaller every single time. And so we're going to plug in to our equation here, a sub 1 over 1 minus r. Our first term is 8, divided by 1 minus our 0.4, so we get 8 over 0.6, and so 8 over 6/10, which is 8 times 10 over 6, which is really 5/3, and so we get 8 times 5, or 40/3, approximately 13.3. So 40/3. Let's try another. This one, you have to be careful because when you plug in 1, 12 times negative 2/3 to the first power, 12 is not your first term in this case, because 12 times negative 2/3 to the first is negative 8. Plus 12 times negative 2/3 to the second. So we're going to add 16 thirds, because that's another 4/9, and then we can reduce from there. And so our first term is not always this number right here. It was in the other case. So negative 8 over our first term, a sub 1, over 1 minus a negative 2/3. So that's really 5/3. Negative 8 times 3/5, negative 24/5, or negative 4.8. Next, check it out again. So plug in 1, plug in 2, plug in 3, plug in 4. You get 3 plus 3.75 plus 4.6875, and so on. So you plug it into your equation. 3 over first term over 1 minus your r, 5/4. First term, 1 minus r. 3 over negative 1/4. And so that's 3 times negative 4, so negative 12. So all these numbers add up to negative 12. Well, that's not true, because 5/4 is bigger than 1. We repeatedly multiply by 5/4, so we're not getting smaller every single time. The only time you're going to get an actual number when you add an infinite amount of numbers, which is crazy to begin with, but the only time you're going to actually get a sum is when r has to be less than 1. Notice, though, that you can still use the equation, and so that is the dangerous part. So keep in mind that r has to be less than 1. All right, typical bouncing ball problem. So you've got a bouncing ball. We drop it from 10 feet, and then it bounces to 4/5. So 4/5 of 10 is 8. 8/10 in other words. So it starts at 10, and then 10 times 4/5 is 8, and then bounces again, so on and so forth, and technically it's never going to stop bouncing because it always bounces to 4/5 of its height. So we said this was 8, this was 6.4, if you keep going, 5.12, and so on and so forth. So what's the total distance traveled? Well, r is 4/5, common ratio. So because it's getting smaller every single time, we'll be able to find this total distance. Now, this is made up of two series. Think of the down part and think of the up part. You can do it a couple different ways, but the down, a sub 1, is 10, and then the r is 4/5, and the up, a sub 1, is 8, because we don't go up to 10, and then the r is 4/5. And so we're going to add two of these together. The sum of the down, or down and up, or we could just do 2 times the up and then add 10. Because it's the up and down, they mirror each other, and then I'm just going to add the 10 for the drop at the beginning, initial drop. So the up is going to have our a sub 1 over 1 minus 4/5 plus 10. So that's 2 times 8 over 1/5. So 2 times 8, and then we flip over the 5. Dividing by 1/5 is multiplying by 5, and add 10. So that's 40. Times 2 is 80. Plus 10 is 90 total feet traveled. And so even though the ball will never stop bouncing, the final distance it travels is 90 feet, which is kind of crazy. Never stops bouncing because it gets so tiny in the end. Now, 0.12, 0.12, 12, 12, 12. So it's repeating. Think of this as a geometric series, because we're adding them up, that this is the same as this. Where a sub 1 is 0.12 and r is 1, 2, 1 100th. So the sum is going to be a sub 1 over 1 minus r. And so it's going to be 0.12 over 1 minus 1 100th. So 0.12 over 99 100ths. And 0.12 times 100 over 99. So if we multiply the 0.12 times 100, that's 12 over 99, and that reduces to 4 over 33, if you take the 3 out of top and bottom. And so that's the total sum, and you could approximate that on your calculator.